Year 8. Welcome to our revision for the midterms in the third semester. Starting off with probability, we have two types of probabilities. We have experimental and we have theoretical. Okay, we have experimental probability and we have theoretical probability. The theoretical probability is not based on examples or experiments or tests, let's say. But experimental, we have the original data, we have a more accurate value than with the theoretical. Today's example is going to be about experimental. Okay? And the same rules apply for both. So let's say the probability of an event called A, whatever it is, it's going to be the frequency of that event, okay, of event A, over the total of frequencies here in experimental probability, the total of frequencies here. Okay. So let's do it here, guys. Starting off with an example, it says a hospital tried to out a new kind of knee surgery on some patients. After 2 years, the patients were asked how they felt. The results are shown in the frequency table. So we have this kind of a surgery which is has its result on a total of a lot of patients, and some of them got good results, some of them got bad results after the surgery. So we having this table in front of us, we will know its actual probability or experimental probability that we would use in medical practice to tell other patients that, okay, that the probability of that surgery is 75%, which is a really good probability. Which is has a higher chance of having, for example, symptoms free or even some improvement. But in medicine we are giving all aspects, not just the good part, even the bad part. So we're gonna tell them also that, okay, there is like a 10% chance of having no improvement at all, or basically failure of the surgery. Basically, when we say failure of surgery, it means we didn't do anything to improve the situation. Using math, using probability, which is part of math, we will give these information to patients, and let's go. So we have symptom free, and we have 60 patients who have symptom free outcome. We have 15 patients having some improvement outcome, and we have 5 patients having no improvement at all. Total of patients is going to be guys. It's going to be 80 patients in total. So having these results is really important in maths. Okay, so let's go and find the frequency of, experimental probability of each. So starting with the first one here, we have 60 patients, which is the frequency of an event, right, over the total frequency, which is 80, as you can see here. So we can show it as a just, as just a decimal part or fraction part, or we can show it as a percentage, as you like. So first we're going to do it as a fraction part. Cancel out the zeros. It's going to become divide both sides by 2. It's going to be 3 over 4, which is 0.75, right? 0.75. So you show it in different ways, in fraction form or decimal form. You can also show it in a percentage form. Take any part you want. Let's say take the decimal part 0.75, multiply by 100. When you multiply a fraction by 100, you multiply a decimal by 100, it will give you the percentage, which is going to be here in this case 75%. Why, mister? Because 1, 2 jumps to cancel out the point, that's why, because we have 2 zeros there and multiplication to the right. So 75% chance of having a no symptoms or symptoms free. Okay, let's go for that's for symptoms free or symptom free patients. Okay, that's for symptom free patients. As for guys, no improvement at all. We have no improvement whatsoever. So when we have no improvement at all, let's go for some improvement. Some improvement. It is gonna be it's gonna be 15 over 80. Simplify it first before we change it to percentage. Divide by 5 and divide by 5. And when you do that, 15 divided by 5, it's going to be, guys, 3, right? It's going to be 3, and 80 divided by 5 is going to be 16. Okay, sorry guys. So that's the fraction part. If you want to show it as percentage, you multiply by 100. So 3 divided by 16, multiply by what, guys? Multiply by 100. It's going to be 18.75 percentage. So 18.75 percentage of having some improvement. So if we had 8 patients, we're going to have about 19 patients having 100 patients. We have 19 patients having some improvement. No improvement at all. It's going to be 5 over 80, which is the same as 1 over 16. And if you multiply 1 over 16 by 100, it's going to be 6 point. If you multiply this by 100, it's going to be 6.25%. So 6.25%. Okay, if you add them up together, 18.75, okay, with the 75% and everything, it's going to be 100%, which is the total patients we have. Okay, now we have our results. So we did copy and complete, work out each frequency. We calculated the experimental probabilities as shown. We took, now we're gonna comment what happens. The hospital claims that the patients undergoing new surgery are very likely to improve. Comment this claim. Before we comment on this claim, I'm gonna show you some kind of thing here. We have this line, number line, okay? We have 0, we have 0.5, and we have 1. Okay, these are whole numbers, not percentages at all. The same shown here, the same shown as 0%, 50%, and 100%. Okay, my hand is a little shaky, guys. That's why I just promised you to do the video. That's why I'm doing it. I'm in no condition to do videos at all. Okay, so let's go over here. If the event happened here, this is impossible. If the event was like 0, it is impossible to happen. The same here works. It's impossible to happen, okay? I'm going to do them with different colors so you can differentiate. If the event happened between here and there, it is unlikely to happen. It is unlikely to happen. Here to there, unlikely to happen. The same here to there, unlikely to happen. So it's like 1% to 49%. It is unlikely to happen, guys. So from 1% to 49%, it's unlikely to happen. If it happened here in the middle, right in the middle here, it's gonna be even chance. It's gonna be even. It's gonna be what? Even chance. It's gonna be what? Even chance. Okay, it's gonna be even chance. If it's happened here, like from 0.6, let's say, to 0.9. Which is going to be likely now. Now it's going to be likely. The event likely to happen. So from 51% to like 99% is going to be likely to happen, guys. Likely to happen. But if it's like happened like at 1 here, it's going to be certain. It's going to be certain, guys. It's going to be what? It's going to be certain event to happen. Certain to happen. Now, giving this scale in front of you, we can answer the question, which is saying the hospital claims that patients undergoing new surgery are very likely to improve. Come on, in the screen. So we have 2 improvements, right? We have symptoms free, we have some improvement. So we can add them up together, add percentages to be accurate. So it's going to be 75 plus 18.75, which is going to be what, guys? Which is going to be 93. When you add them up, these two together, it's going to be 93.75. Yeah, so 93.75%, right? When you add up these two improvements, because no improvement, of course, not improvement at all. And when you add them up together, look, 93.75% here, this one here. Is it likely or is it unlikely? Or even, or possible, or certain? Yeah, it is, of course, likely. It is like here, so it's very likely to happen. Such a thing to be happening. So are very likely because it's more near to the certain part. That's why we say it's more likely to happen, because the percentage is showing this that you added and everything would answer this question. And and showing the scale also when the question asks you to comment on such a thing, show the scale, show the percentage, how you got it and everything, and show that you have a good reasoning and you get the full mark, inshallah. Okay. The next part here, we're going to go for percentages of an amount. Inshallah, I'm not forgetting anything. Percentages of an amount, which is really important topic to revise. Okay, so we have percentages of amount. Here we have 20%, for example, of 30. So 20% is going to be 20 over 100. Off means multiplication, and 30, leave it as it is. Cross the zeros out together, cross the zeros out together. 2 times 3 is 6. So basically, 6 is 20% of 30. This is the meaning of percentage of an amount. Another example would be, for example, 5% of 400. The same thing, 5 over 100 multiplied by 400, as you can see here. Cross the zeros out, cross the zeros out. 5 times 4 is going to be 20, guys. It's really, really easy, right? So 20 is 5% of 400, which is really, really important thing to know here, guys. Another topic we were going to discuss here, percentages increase and percentages decrease. Percentages, we have something called percentages increase. Okay, when you have add up, appreciated add up result, increased, inclined, and we have percentage decrease or reduced. Reduced, very key important word, which is reduced. Okay, declined, depreciated. These are all decreased. So we have two formulas. If it's increased, it's gonna be addition. 1 plus the multiplier we have times with the original amount. But when we have such a thing like this one here, we're gonna change the addition sign to subtraction. It's gonna be 1 minus the multiplier multiplied by the original amount. So 1 minus the multiplier multiplied by the original amount, that's called decreased percentage, which is in front of you using the formula. So if I told you that I have some kind of t-shirt or whatever costing $300, okay, and it's in the sale now in about 10% sale, reduced amount. So what's the new amount? First of all, you're gonna do 1, it's reduced, so decrease, minus or plus, of course minus. Minus what? The multiplier. The multiplier is basically the percentage divided by 100, which is gonna be 10 divided by 100, and when you do that, it's gonna be 0.1, right? So 1 minus 0.1 times the original amount, which is 300 in this case. So it's gonna be 1 minus 0.1 is actually gonna be 0.9 times it with 300. When you plot this in your calculator, it's gonna be 0.9 times with 300, guys, which is going to be 270. So the new amount of the t-shirt, whatever it is $270. Using the formula, you can plot it, and everything is going to be right. Okay, so I showed you this one part. This part is really important, and this one here, this differentiates everything. This sign here differentiates everything, which is a really important thing. The last thing to talk about here, guys, is the unit ratio. Unit ratio, when you have a ratio of 7 to 5, for example, or whatever it is. Okay, 7 to 5, for example. Show this as a unit ratio. So we're going to choose what? You're going to choose the smaller amount, and you're going to divide both sides by the same smaller amount, which is going to be divided by 5. Divide by this 5 in this case. And when you divide 5 by 5, it's obviously going to be 1. That's why we call it unit ratio. And when you take 7 divided by 5, obviously it's going to be a decimal, which is going to be 1.4. So 1 to 1.4. That's all. That's all. So basically take one of the sides and make a unit ratio by dividing by the smaller amount called the smaller factor. So if you divide this by 5, it's going to give you multiply this by 5 is going to give you this 5, and 1.4 multiplied by 5 is going to give you 7. So that's why we call it a unit ratio, guys. It's really important. Take care.